Everyone. First of all, if you see a watermark on the top right corner of this, that's just something like powered by Screencastify. Please forgive me for this. I'm using a free version of this, so that's why I came with it. Another thing, I was just testing this block of code here, from the last video on generating points on a circle. I added in like an error tolerance. It's to kind of make up for rounding errors because as like last video, I kept getting I got false like pretty much every time except for that one time where I used only 4 points. So that's what this is for. I'm gonna calm this out for the time being, because I'm gonna be putting stuff out to the console and I don't want this to get in our way. All right. Today's video is going to be about generating points on. I'm going to show you how to get 3 points on the sphere. So, like the algebraic way you would do this, it would be like x squared plus y squared is equal to plus z squared is equal to a radius squared. I think it's squared. Double check for me. And if you want your horizontal, vertical, and depth translations, there's an extra translation here. You just do your x minus h, y minus k, like you usually would, and then z would just be minus l on this. All right, I use this double star for exponent. If you're used to seeing characters, that's fine. I can change that, but this is not here to stay. Right, so the way we do this, the way we use this equation is, I mean, of course, we can just like simply brute force find all the points, but I think the way you're supposed to do it is the way the programs do is they use rings to generate this. What I mean by this is we will hold we will hold like z constant if you want like the if you want the rings that are coming here. I'll draw a picture. I can't draw a picture because this is recording my tab. Anyways, yeah, you'll hold z constant if you want the rings are going upwards, and you will hold the x or y constant. I forget which one. If you want to get the rings going sideways. Well, I'll show you how to do one, and I'll show you how to do one in video, and I will leave code behind, kind of off recording, to I'll still have code here that does the rings going sideways. I'll show you the ones going out vertically. Okay, this one is getting really unreadable. So if we hold z constant, that basically means we move this to the other side ideally, so that becomes h squared plus y minus k squared is equal to r squared minus z minus l squared. See, I leave a space between. Nope. For the last video, I may have changed the name. It's been a long time since I've recorded. Yeah, just simply call it F. It takes in takes in a center point h and k. So this will make you your this part of the equation. And then let me print this. This is more updated. So this will give you this half of the equation. This is what your h and k will give you. The r is no longer just this one because you have an extra term here. So you would have to take the square root of that. Actually, for simplicity, be math, not coding, as I casually code on screen. All right. So if this is correct, let me actually test this. So I'm going to call. I'll make some points here. Let's do. So 0, 0, and radius will have to be square root of that whole thing. Did I mess up again? This is going to break, is it? All right. Radius will have to be square root of. Okay, we'll define an r that is. So 4 squared minus. I want to L to 0, so that's going to be 0 squared. I'm leaving the 0 here, just kind of emphasize that we're using 0, 0, 0. Number of points, I don't know, 6. Is that is that good enough for you? I'm nervous about this. I'm gonna go give it a try. I'm gonna cut this. Oh, okay, I see what's wrong with this. Sorry. Let me figure this out. I'll come back. I think I see what's wrong with this. All right. It turns out that what I've been doing wrong is not as bad as I thought. It's still pretty bad. What we do is I think y is constant and x and y become your z, so it's become like x squared plus y squared is x squared plus z squared is equal to r squared. So this function starts to become, well, the parameter names become less relevant, but it still does what we want to do. Here, I'll generate some points for you. Let's do 0, 0, 0, radius of 4, and we'll do 6 points. But these points, these are still your x points, but rather than these being your y points, these are actually your z points. So we apply this. Well, I can't open another tab because then it won't record that. So we can still find like another ring. So let's change delta by say 1 unit. Then we'll go x is 0, Y is now 1. No, I'm sorry, Z is now 1. Uh, we'll still want 6 points, but now we don't know what goes in here. We calculate the radius of this new point, which I'll need some paper to figure out. I believe it's like 4 minus. I believe that as a question mark. I'll fill that in. Anyways, I will I'll plot these points on the next tab. All right, so two things. First, I have plotted the points, the 6 points that we found earlier. Also, have added an additional ring up on top. I know what the front looks like. It looks like there's 2 lines, but if you rotate it, look at that. It's starting to look like a sphere. Right? I will post a code in the description, um, but I am thinking about posting this URL in the description. But um, I have found some problems, such as like if you try to rotate along the y-axis, you see I have a very left point, and rotate along the z-axis, you get this problem. All right. So until I fix it, this won't be posted. All right. So don't rely on it. And if you have any questions, concerns, such as if you run into other problems other than one that I showed on here, to post it, and uh, and I will respond to that probably. And I hope you found this helpful, and I'll see you in the next video.